Hi and Assalamualaikum. Throughout this video, we will be talking about introduction to differentiation and related rate, problem statement to the question, problem solving of the question, and we will end it with a nice conclusion.
So first, what is differentiation? Differentiation is a process of finding the derivative or rate of change of points. Basically, why we use differentiation in math to find tangent line or maximum or minimum points for a graph. Besides that, we also use differentiation for to determine the function if it's increasing or decreasing. For example, a function is decreasing if its derivative is always positive, and a function is decreasing if its function is negative. So the application of differentiation in math is defined as the rate of change of one quantity with respect to another, which is it's defined as dy over dx or fx. So they have various important applications like increasing and decreasing function, tangent and normal to a curve, minimum and maximum value, and last is rate of change of quantity.
What is related rate? Related rate is a process to find a rate at which a quantity changes by relating that quantity to other quantities whose rate of change are known. Related rate is usually used by engineer and science. For this question, we use related rate to find rate of angle. In order to use related rate in this question, first of all, we need to know what we want to find from the question. Based on this question, we use related rate to find the rate of change. Then, we need to take out all the information that had been given in this question, like dx over dt equals to 0.35, x equals to 1. After that, we need to differentiate the equation that had been given from the question. Next, we use the chain rule and we substitute the information that we have. After that, we solve the equation and we will get the answer.
So now, I'll be talking about the problem statement. An aeroplane flying at 450 km per hour at a constant altitude of 5 km is approaching a camera mounted on the ground. Let theta be the angle of elevation above the ground at which the camera is pointed. When theta equals to pi over 3, how fast does the camera have to rotate in order to keep the plane in view? Our main objective is to find the speed of rotation of the camera to keep the plane in view, which is d theta over dt. So how are we going to do that? Well, let us pull out some words that can give us some clues to find the answer. First of all, it mentions about the airplane flying at 450 km per hour and also at a constant altitude, which is also known as the distance between the plane and the ground is 5 km. And lastly, it mentions about the angle of elevation, which is theta equals to pi over 3, which is actually known as the camera's maximum limit to rotate to keep the plane in view. So during the problem statement just now, we managed to visualize how the position of the airplane and the rotation of the camera. We are going to say that the opposite is y equals to 5 km, while the adjacent is an unknown value, while the radian is theta equals to pi over 3. The first step to be taken to solve this problem solution is to find the value of x. To find the value of x is to use the Sofea method. To use the Sofea method, we need to figure out what is the opposite, what is the hypotenuse, and what is the adjacent. Since we are only given the opposite and the radian, it is clearly known that we need to use the TOA method, which is tan theta equals to opposite over adjacent. So to find the value of x, first of all, we are going to change the radian to degree. So pi over 3 times 180 over pi is equals to 60 degrees. So we will substitute 60 degrees to the theta. So we are going to use, as the displayed solution, I'll be saying that times 60 degrees is is equals to 5 over x. This is a very crucial part that we need to know that we are going to use the values of trigonometric ratios of the special angles of 30 degrees, 45 degrees, and 60 degrees. Since we already know that tan 60 degrees is being used, so we are going to sub it with square root 3. So x times square root 3 is equals to 5. Therefore, we are going to get x is 5 over square root 3. Since we've already managed to solve the value of x, we are going to find the speed of the rotation of the camera to keep the plane in view, which is d theta over dt. To start off, we need to use tan theta equals to y over x, and then we are going to sub 5 into y, which is tan theta equals to 5 times 1 over x. Why did I did 5 times 1 over x? To visualize that 5 is a constant while 1 over x is the variable. So x can be shown as also x to the power of negative 1. After that, we need to differentiate both sides by using the implicit differentiation. When we differentiate, we are going to get secant squared theta times d theta over dt. And then, while 5 remains constant, x to the power of negative 1 is differentiate to negative x to the power of negative 2 times dx over dt. You can also change the secant squared theta to a much more simpler way, which is 1 over cos squared theta times d theta over dt equals to negative 5 over x squared times dx over dt. So we've gotten the complete equation, but first of all, we are going to list out what we need to substitute into the equation. The first thing is that theta equals to pi over 3, while x equals to 5 over square root 3, and dx over dt is negative 450. You might be wondering, why is it negative 450? Well, since we already know the speed of the airplane is equals to distance over time, so we are assuming that x is the distance. Since we can see that the plane is moving towards the camera, the distance between the plane and the camera is getting shorter. So therefore, we are making it as negative 450. To substitute the following values to the equation, we will get the end product of 4 times d theta over dt equals to 270. So we are going to make 270 divide 4. So our final answer to this problem statement, which is d theta over dt equals to 67.5 radian per hour. So that's the final answer to this problem statement.
So last is conclusion. So in a conclusion, we using differentiation in related rate to find rate of angle. From problem solution that you can see, all problem that we solve, yes, surely using step by step. First, we use trigonometry like tan to find x, which is the distance between the camera and the airplane. Then we use the related rate to find the how fast or the speed of the rotation of camera. Thank you for listening till the end. I hope you guys will enjoy this video. Bye bye.